Hello all, welcome to my channel. So today I'm going to talk about embeddings. So nowadays you see in natural language processing embeddings is very popular. So also today what I'm going to do it, I will show it execute it in a notebook, Jupyter notebook. So the code I given the location in my GitHub repo, so you can clone it and you can also execute at your environment. So again, coming back, as I said that what is embeddings is very popular in natural language processing. So nowadays you see that when you work with your like AI application, sometimes you do product chat or you are trying to find a semantic search meaning or finding what the sentence is trying to tell, the similar sort of meaning, or say the clustering, classification, lot of things you try to do in that. So embedding is very handy into that. A computer normal doesn't understand the text whatever you input it understand in terms of the number. So where what embedding does, it takes a text and then it converted to a number of array. So for example, in this example, like what I'm going to show it today, I use a 768 dimensional vector space. So there are like different embedding model. You can also change that figure like so that you can put more attribute to that. Although I'm doing the lesson for today is a text embedding, so there are also similar thing is there in the image embedding you can do. So let's try to understand what is a text embedding. So when you give a text to the embedding, it converted to, as I said, that into a array. So numerical array. For like if you see in this example, I say that I given a two sentence like I love dogs, and I just put some of the embeddings like it is not real things. I'm just trying to make it to understand. So some of the dimensional like the 760 dimensional numeric values, it try to show it to you. The similar way, let's say that I'm taking another like sentence called puppies are adorable. So it also created the number of embedding into that. And the third sentence I take something called the stock market crash. It's also when you give it to the embedding, it also will create a numerical array into that. Now, when you take these numerical arrays, you can then plot it to a graph. Like you can like and can find the cosine similarity. This is one of the similarity search you can do it. That how the two sentences are correlated or similar in terms of meaning. And there is a formula. You can follow that formula. Also, I'll try to show it in terms of my code when I execute it. You can see it. So the the angle like is the value is one, it become like a more of similar or similar to that. Let's say that you got 0.9, 0.8, so it is more similar. And let's say that the value becomes zero, the one is a perpendicular, so that means they are unrelated. So having said that, now let's jump into the code and try to see how it is working so that you will get a feeling and you can execute at your environment. So as I said that it's there in my this code is there in my GitHub repo. You can take it, can execute at your environment. So the repo I have already given in the description. You can take it from there. You can install, take that location of that. Uh, these are some pre-required libraries to run it. As I say that I'm using sentence transformer for the embedding, but there are a lot of other models are available in the market. OpenAI or from Titan embedding, you can use whatever you like that, but you need API key in that case. In this, the sample, whatever I used, you don't require anything. You just install the libraries, then you are happy to go ahead. So like I just write a helper function, like when the sentences, the text you will give it to that, it will create the embedding into that. So let me just try to take a single word and see that what you can see that how the embedding create into dimension, what are the values, the numerical values you see. So in this case I'm executing it again. So as I say that I'm using a 768 dimensional array. The first 15 values I'm putting it here. You can see some of the numerical values what is coming out of here. So the first 15 cent. Now let's just put it on a graph to see that how these values are coming in a graph. So if I just I'll rerun it again. So I already ran it once. So you see this, but in this case I'm just plotting it 100. There's no point in putting a 768. It become. too overwhelming. So you can see that how that sentences or the, this word, the rocket, has been represented here into this dimensional array. So now let's just take this and take a step further. From the word, let's take a sentence. For example, here I'm saying that artificial intelligence revolution in healthcare. Let's take it and also we'll put the first, as we saw that the first 15 values from the our array, and you can see that a lot of numerical values it comes. Now the cosine similarity, let's say that we're putting into two sentences, and we are trying to judge that what is the similarity between these two sentences in terms of the meaning, like not only in terms of the word but the meaning of the context of that. So what, the more the value is close to zero or the angle is low, it's a more similar in nature, and more they're drifting apart, like almost go up to the 90 degree, then they are not related. That's the kind of thing. So there is a formula, you can follow this formula. So I've written a little helper function for that to calculate the similarity. So we'll call it, and let's execute one of our example here. So I've given like three sentences here. So I adopted a golden retriever puppy yesterday. My dog is very playful, energetic. Similar line, whatever I was trying to show it into the example I've shown earlier. The stock market crashed today. So let's just run it and try to see it. So you can see that the A and B, the value is coming like for example 0.4. So it's a similar sort of thing is coming, like it's coming less because it's both about dogs, so they're related. So similar, like when I'm putting A against C, you can see the value is going like 0.1240. So they're drifting apart because dog and stocks are not related. And the similar thing also happened like between the B and C, like B and C, they are not related. Again, it's about dog crash market, nothing related. Let me just now take a few more sample, like when you execute at your place, you can take more and more, can see it exactly how it behave. So I'll give a like a around five sentence, like talking about like machine learning models, training data, neural network require of example, I'm planning to vacation high, my trip to beach next month, climate change kind of thing. So I'll draw a heat map trying to see that, like how it plot it, like when I'm comparing like between S1 to S1, the same sentences is the same, so the value one is coming. So the point I'm just trying to show it here is that if it is similar, for example, like S1 and S2 is similar, so S1 is talking about our machine learning models and training data, this training data, and S2 talk about like neural network, a lot of examples, so they are related. So let's see that S1 and S2 score, uh, so which you can see the 0.452. The similar way, the other example you can follow it exactly. So the value or the context mean is coming, you can see the value is becoming nearer to one, so that they're similar of nature. So that's one of the things that I'm trying to show it. So keeping on to the next example of it, I created some sort of a like a document, like where I put some of the values, like how to train a neural network, image classification, some of the example I've given, and created documents. Later I'm just trying to do a semantic search out of it, like I'll give some value and which are like coming nearer from that database. For example, here I have given three queries. One query I'm talking about like not deep learning and AI, outdoor activities, nature, food and recipes. From this, like you take it and show it to me. So this is a helper function in between. Now what will happen once I will send my queries, it will go and source this document and find out. For example, the first thing I'm talking about, like deep learning and AI, the related topic, the document whatever I've earlier given to, based on that it got some values like understanding background in deep learning or convolution neural network, the similar sort of topics. It is coming with a score and it is showing to the value. So similar, the next query I'm trying to do with outdoor activities and nature. In that document, I've given a value of like, the hiking trails in Rocky Mountain, or visit summer in families, growing tomatoes in a backward, like related to nature, what was coming. The same thing goes with the food recipe. So you can see that how when you try to query the semantic search, the similar sort of meaning, whatever is coming, I'm showing us the result to us. The last one, This example I'm talking about, like, when you try to do some FAQ in your website, you give some values, like I've given like FAQ question, these are my question, user questions, like kind of thing. So I can, like, user asks, I forgot my login credential. So best match is that, like, how to reset my password, or similar sort of things, whatever the values are coming based on the embedding. So the purpose of this video is trying to give a very basic knowledge about embeddings, how it works. So what happened in the AI exactly, like when you put a sentence, try to search that similar things, or try to go to knowledge base, and try to see that the similar nature of like responses will come to you. So I hope you find this video useful. As I said, this is a basic. You take this notebook, try to execute on your own, try to see that how it's behaving. You can also try with other like models. As I said, that you can try with OpenAI models, or a Titan embedding, other embedding models. You can try to see it, how it behaving. uh, Thanks for watching this video. I hope you find it useful. Keep subscribing to my